Hello and welcome to another Learn Computer Science video. In this video we're going to be talking about how magnetic hard drives work. And in order to show you how they work, I've created a few animations using Scratch because I like Scratch. So if you want to have a play along with that, I'll put a link to each of the Scratch projects in the comments section. Okay, so let's get started. So the first thing we need to have a look at is what is a hard drive made up of. So let's have a look. Here we go. So a hard drive, the main components of a hard drive, you've got the case. That sits on the outside, that protects all the components and holds them in place, usually made of metal. And on the case, we have a controller. And what the controller does is it talks to the CPU, and whenever the CPU, the rest of the computer, needs some information, needs to have a reading from the hard drive or writing to the hard drive, then the controller will send the electrical signals off to the rest of the components to do that. There we go, and you can see the little wires there that run along. Okay, so we've got the controller. Then attached to the controller is a spindle motor, and the spindle motor spins the disk platter. It controls how fast it spins. It normally spins, depending on what type of hard disk you've got, it will spin at about 7,200 RPM, revolutions per minute, which works out at about 120 times per second. So this is spinning pretty quickly. And what happens is, as that spins, you also have an actuator, which is another motor, and this actuator controls the actuator arm. And there you can see is the actuator arm. And as the disk spins, the arm moves to the portion of the disk where it needs to read from next. And when it gets to that point, the job of reading and writing is done by the read-write head, which sits right on the end. It doesn't look yellow and it doesn't look like that. It's actually incredibly tiny, but it sits right on the end of the actuator arm, and it's a little sort of electromagnet that can be used, and it can either be used in one of two ways. It can either be used to read or it can be used to write. Okay, so let's have a look at what's going on that platter with the head. So first, let's have a look at read mode. So as we said before, we've got the surface of the platter, and the surface is coated in tiny little regions of ferromagnetic material, and each of these little regions, these little parts here, can be polarized north or south, which is the equivalent to a 1 or 0 with data being stored. So you've got this data stored on the platter itself, and then you've got the actuator arm here, and it moves across the surface of the platter, and as it moves across, the read-write head goes across each of these sections, these segments. And as it gets to a polarized segment, what it does is a tiny little current, either a positive or a negative current flowing one way or another, is generated due to the magnetism here affecting the coil, and it sends a tiny little current which is then read by the controller, and that determines whether it is reading a 1 or a 0. And it just does that incredibly quickly, and you can see it here. As it goes over the blue ones, it's recording and picking up a 0, and as it moves over the red sections, it will pick up a 1. There we go. So that's how the read mode works. Really quite simple. Obviously, there's all sorts of things that can go wrong. There's interference, corruption, and those sorts of things. And advances in hard drives have allowed us to be able to read quite accurately using a lot of different techniques. Okay, so that's read mode. It just reads, it creates a little signal and it sends it down the actuator arm, which is red. So what about write mode? What's happening there? Well, write mode, it's pretty similar actually. You've still got the platter, the actuator arm is spinning. But all that happens is anytime the computer wants to write data to the disk, to any particular section, all it does is it sends a tiny little current along the coil, which is just enough current to be able to flip the polarity of the section that it wants to change. And again, it's doing this incredibly quickly, reading and writing as it's going through, depending on which segments need to be read or written. There we go. So that's how magnetic hard drives work. Obviously, as hard drives have increased in capacity, we need to store more and more data. And one way they've achieved that is what they did is instead of just having a single platter and a single actuator arm, with modern hard drives, a lot of the time we stack multiple platters with actuator arms on top of each other. Which means that, do you have twice as many platters, you get twice as much storage of data. And in this case here, you can store 4 times as much data. There you go. Okay, so let's have a quick review. So, data is contained on a platter that's coated with ferromagnetic material that can be magnetically polarized north or south. And the read-write head moves over the surface of the disk, and it can either be read through measuring the magnetic field, or it can be written by sending an electrical signal through the head itself. And the only other thing to cover now really is the advantages and disadvantages of magnetic storage, especially magnetic hard drives, when compared to other devices. So advantages, well, they have a high storage capacity. Modern hard drives can store over 2 terabytes quite easily, and they're quite cheap. I mean, this technology has been around since the 1960s, a series of advancements, which means that for price, especially for the storage capacity, it's really, really cheap. You can get one for, a new hard drive for probably $30 or less, which is brilliant. And they're really reliable because they store using magnetism, and that magnetism can actually last up to 20 years. They normally say between 10 and 20 years, even without turning the hard drive on, it will just sit there, which is more reliable than some of, especially SSDs, which can only last up to 5 years before you start to lose some data due to the way that they work. Disadvantages of hard drives, well, you've got quite a lot of moving components. You've got the motors, you've got the platters, so they're quite heavy. So they're not much use in ultralight devices like your ultralight, ultra-thin laptops or for mobile phones. So they're no good for that. They can be easily damaged when drops as well. If you've got this spinning platter where the read-write head is only sort of 5 billionths of a meter away from the platter, if you drop it, that read-write head could very well go and hit the platter and damage the platter. So that can cause problems. Also, because you've got all these moving parts, like the motor, the actuator arm, and the spindle motor, you've got a lot of moving parts there which require energy to run, which means they take a lot more energy than SSDs, other storage. So they're not much use in devices where you need to be really, really careful with the amount of energy use. So, for instance, mobile phones or tablet PCs or anything like that, e-readers, because it's going to use too much energy. So that's no use. And also is because the final reason is they're slower than some drives, so especially SSD drives. Because you've got these physical moving components and the actuator arm has to physically move from one portion of the disk to another portion of the disk to actually read it, although that is incredibly quickly, is moving incredibly quickly, then it's still going to take time rather than storing data in a SSD format. Okay, so those are the advantages and disadvantages of magnetic hard drives. As I said, I'll put all the resources for this in the comments section. I'll put a link through to them. And if you have any questions or comments, then please add them. And if you did like the video, then please like and subscribe. Thank you very much.